It's me, Mario!
Hello guys, we are the
Bytecode.
and I'm the leader of this group. My name is Emmanuel Dimisola.
My name is Jemani Sean Gabriel Pentingue.
My name is Jared Omnes.
And my name is Raji and Declaro.
And
Let's
let's
do
do
Arduino 101.
So hello guys, so this is the Arduino project. So the Arduino project that we made, or the program that we made, is that we will allow us to monitor a person's heart rate, or the BPM, and the oxygen saturation level, which is the SpO2, using a max 3010 pulse oximeter sensor. So the data will be displayed on the OLED with a health status indicating it's normal or low. Also send a web dashboard via Wi-Fi. Then a buzzer will stimulate an heart rate sound based on detected faults. So that's it. So that's the demo, or the Arduino project that we are proposing. So guys, so this is the materials of the Arduino project that we made and the heart rate monitor system. So ESP32. So dev kit C no DMCU. It's the dev kit that compact development board that built around the ESP32 microcontroller from the ESC CF system. It integrates Wi-Fi and Bluetooth capabilities, making it ideal for IoT applications. Basically, it has Wi-Fi, etc. And it has more memory and hertz, CPU hertz. So next, another item that we using is the pulse oximeter. So pulse oximeter is used on the to measure heart rate and blood oxygen levels. It's a compact sensor that both works by shining red and infrared light through your fingertip or earlobe and detecting how much light is absorbed by the blood. This method is called the photoplethysmography. So next is the buzzer. So a buzzer is a compact audio that signaling device that produces sound, usually a beep, buzz, electricity, and it's widely used in electronics to alert users when production or signals warnings. Next is the 0.96 OLED display module. So this compact OLED is used to display text, graphics, and add simple animations and embedded in projects. It features a 0.96-inch screen with grips with wide pixel and communicates with microcontrollers like ESP32 and or Arduino using the I2C protocol, which only requires two wires, SDA and NCL, and the power, which is the GND and BCC as well. So next is the jumper cable. So jumper cable is used for electronics to connect. This is the male to male. So this is a flexible that has the male connectors on both ends. So that's it. So next is the jumper cable for the female to male. So this is connect on the socket of the on the end. It has a connector, and the other end has a socket. So making them ideal for linking sensor, module, or board that don't fit directly into the breadboard. Then another is breadboard. Is the compact solderless prototyping. So this is the prototype that used for the Arduino to build or test circuits without permanent connectors, and this is available for inserting a number of points like jumper wires, resistors, etc. The next, for our materials as well, we're using a cardboard. So cardboard is a thick paper-based material commonly used for packaging and crafting. So we use that for crafting, and the compressed layers of paper can be varied in thickness and strength depending on its extended use. So that's it. So hello everyone. So this is the Arduino project that we made. So the title of this is the heartbeat monitor system that where we will be monitoring the BPM or heart rate of a person and its saturation or oxygen saturation as well. So I'm be explaining the source code of this. So first we have tons of included libraries here. So wire. So wire is used for PC communication to the OLED and MAX sensor that we are be using. Then UAG to live library is used for OLED graphics. Then MAX is 305 is used for our sensor. Then for the another library is the SPO2 which used for algorithm to implement the segments of the heart rate and SPO2. Then Wi-Fi is used for the uh, ESP32 Arduino that we are using, and then we're going to create a local web browser. So we're going to use a web server. So in here, so we'll be using a PC setup. So SSID password. So here, then web server is the server which going to host on the port 80, which is the standard HTTP. So next is the sensor OLED. So we're going to set up the sensor OLED here, particle sensor, and then the OLED setup here. So the sensor is the OLED. Then pin buzzer, we will be using buzzer as well in here. So 25. Then uh, finger threshold. This is the HR level to detect if a finger is detected on the sensor or not. And the buffer size, which is 100. This is the number of sample observed for analysis of the heart rate of the sensor as well. So here, there's a buffer here. So next is the buffer. Buffers, that's the buffer size. We'll be using the buffer size. Then the HR algorithm. So in HR, then this average size is 5, then HR is 3, and finger detection is going to use this for finger detection. So next is we're going to check another here. So as you can see, there's a smooth HR. So this function is how we be knowing if the HR is smooth or not. So HR index is equal. We're going to store the new HR on the index or the array of HR history. Then using that, which is the main then after that, you were going to do the SPO2 algorithm. So this is the variables of the H2 SPO2 algorithm. So after that, so here we'll be using as well icons or bitmaps for the OLED. So that's the bitmaps of the code. Next is the HTML page. So here we will be seeing the website. As per how this works, so we're just implementing the website by storing that into a char and array. So our raw literal. So after storing that all the things is we're going to use a web handler. So we're going to send the server send 200 text HTML to the main page. Then we're going to handle the data by storing that into a string JSON. So backend. So string is get this to store that in the HR and SPT as well. Then send header, access control, we're going to send, then server send into the JSON application JSON, and that's it. So void setup is the serial begin 9600. So we're going to check the SpO2 and HCO2 if they are working. So we're going to debug as well. So delay, then war begin. So war begin 2122, then which is the OLED and the sensor. Then 08 0 C O no U8G2. So we're going to begin the OLED as well, and then pin mode. Then digital right is we're going to set the buzzer as an output, then load this as well. So as the practical sensor begin, so we're going to check if the sensor is there or connected, and after that we're going to do another buffer checking if the sparkle is available, then check, then get the red, get the IR. So this setup is used for checking the sensor. So Wi-Fi begin, which is the password that we stored, then connected, then if not connected, it's gonna just print serial dot dot dot, and if it's connected in Wi-Fi connected, then it will show the IP. And with that IP, you're going to put that local IP to any website, any web browser that you have, and then you will have your own local web browser as well in that. So next is the server on handle data begin. So that's, and another facts about this, that you need to connect your Wi-Fi, the same Wi-Fi devices that you connect your Arduino in. Then the void word loop is the server on the client. Then ship buffer, we're going to reship that, and as well another while loop. So we're going to check if the finger is selected or not. So here we're going to see if the average is greater than the finger threshold, or the things wait, let me check that. It's about like 30k. So if it's 30k, it will detect a finger. If it's not gonna run. So we'll just check. It's not, then last time bit. So this is the algorithm that checks the average last time. So BPM is 600 UL interval divided by that. So the maximum heart rate and saturation. You see this, then last HR, then valid. So we're just checking if the heart rate is valid or not, or in the last HR or heart rate, and SpO2 as well. So last the buzzer read, going to use this as well. If not, no tone. So OLED update, we're going to just update that. If there's a finger detected, set the font now. Then HR low normal. Then HR high, just check if it's high or not, or the SpO2 low. Then heart big number, HR big number. This is the bit maps of the there. So BM ship right. So we're just adjusting the text. Then after that SpO2 value, then set the BMX SpO2. Then else, if it's not detecting, we're just going to place a text in the OLED to place a finger. So there. So just not detecting anything, it will just say place a finger. Then USM the buffer back to the OLED. So that's the code of the project, or the heart rate monitor system. So guys, so madami akong binago. Same lang yung usual. So may website dito. So yan. So kapag yan ako yan. Wait lang. Actually, yung ano na yun, S puto. Huwag na yan, mo na yun. Basta normal yun. Hindi ito. Bumataas yung heartbeat ko. So yun, may ano din dito. Kaya may sleep. Pero alam mo yung visual. May alert. So that's pretty much it. Nagawa na ng logo. Pinasentry ko lang yan, ano. Raise fingers sa ilalim.
Mario!